Hi, welcome to Geometry, Congruent Triangles. This is section 4.1, Congruent Figures. The objective of this lesson is to recognize congruent figures and their corresponding parts. Your essential understanding is that you can determine whether two figures are congruent by comparing their corresponding parts. A key concept of this section is congruent figures. The definition: congruent polygons have congruent corresponding parts. Corresponding parts means the parts that match. They're matching sides and angles. When you name congruent polygons, you must list corresponding vertices in the same order. So the ones that match have to be listed in the same order. An example here, we have this quadrilateral ABCD. You'll notice that the quadrilateral EFGH is flipped, but the corresponding parts, A matches to E, B matches to F, C matches to G, and D matches to H. It's essential that you name these parts in this order. So when you're saying that these figures are congruent, you're saying that ABCD is congruent to EFGH. If you listed the letters of the second quadrilateral in a different order, then you would be incorrect. When we name all of the corresponding congruent sides, these are the sides. Segment AB is congruent to segment EF. Segment BC is congruent to segment FG. Segment CD is congruent to segment GH, and segment AD is congruent to segment EH. So 1 matches to 1, 2 to 2, 3 to 3, 4 to 4. Also, the angles that correspond are congruent when two figures are congruent. So angle A is congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. Congruent polygons have congruent corresponding parts. Corresponding parts are like matching parts. Look at example 1. Find congruent parts. If HIJK is congruent to LMNO, what are the corresponding congruent parts? So you'll notice that the pictures, they're not facing in the same direction. It's rotated and it's flipped. What you should do is look at the letters. H matches to L, I matches to M, J matches to N, K matches to O. So if I look at just the way the letters are ordered, I can name the corresponding congruent angles and the corresponding congruent sides. Angle H would be congruent to angle L. Next, I would have angle I is congruent to angle M because I and M come second. What would be the next pair? Yeah, angle J is congruent to angle N. And then finally, angle K would be congruent to angle O. Those are all of the corresponding congruent angles. If we wanted to name all the corresponding congruent sides, you would then just name the sides that correspond. So, in this case, the corresponding congruent sides, it would be like this, HI and LM. So, HI is congruent to LM. these segments. The next pair I could say would be IJ and MN. So it's really that easy. You have to name the letters that match. So I matches to M, so it goes first, and it goes first in the other. So on and so forth. JK to NO. These are all corresponding congruent parts. And then finally, you would say KH or HK. It doesn't matter how you name the first one. What matters is how you name the second. If I named it KH, then K corresponds to O. So I need to say OL. So what are all the corresponding congruent parts? These are all of the corresponding congruent angles and all of the corresponding congruent sides. This is how I would mark all of the corresponding congruent angles. 1 arc to 1 arc, 2 arc to 2, 3 to 3, 4 to 4. And this is how you would mark all of the corresponding congruent sides. 1 dash to 1 dash, 2 dash to 2, 3 to 3, 4 to 4. The sides that match are the congruent corresponding parts. Example 2, using corresponding parts. Suppose the triangle XYZ is congruent to triangle ABC. If the measure of angle X is 62 degrees and the measure of angle Y is 35 degrees, then what's the measure of angle C? Well, first label your picture with all of these things. So we know that angle X, which is 62 degrees, corresponds to angle A. Angle Y, which is 35 degrees, corresponds to angle B. Angle Z corresponds to angle C. So we could use the triangle angle sum theorem to find the measure of angle Z to find what is the measure of angle C. Because we know the measure of angle X plus the measure of angle Y plus the measure of angle Z equals 180, we can substitute in the values of X and Y to solve that the measure of angle Z is 83 degrees. And if angle Z is congruent to angle C, because the triangles were congruent, these are their corresponding congruent parts. Therefore, C would be 83 degrees. Example 3, finding congruent triangles. Are the triangles congruent? Justify your answer. Well, if you're looking at these two triangles, can we determine whether or not these two triangles are congruent? We know that angle A is congruent to angle E. We know that angle B is congruent to angle D. Do we know that angle ECD is congruent to ACB? We do, because these are vertical angles. We're also given that segment AB is congruent to segment ED. We're also told that BC is 4 and DC is 4. Therefore, they're congruent. And AC equals 6 and EC equals 6. So, are these two triangles congruent? Yes, because all of their corresponding parts are congruent. So again, let's take a look at this. Angle A is congruent to angle E, and angle B is congruent to angle D. That was given to us. Angle ECD is congruent to angle ACB, because they are vertical angles, so using the vertical angle theorem, they are congruent. Segment AB is congruent to segment ED is given to you. BC is congruent to DC, and AC is congruent to EC, because they're equal. Therefore, triangle ABC is congruent to triangle EDC by definition of congruent triangles. It's essential that you write the letters in the correct order. If you write triangle ABC, then you have to write EDC, because they are the corresponding parts. How about this one? Is triangle ABC congruent to triangle CBD? Justify your answer. What do we know right now? You're given that segment AD is congruent to segment CD. We also know, because both of these triangles, triangle ABD and triangle CDB, have this segment, DB, is congruent to itself by reflexive property. They share it, and therefore it's equal to itself by reflexive property. But because we only know those two sides, and we don't know anything about AB and CB, and we don't know anything at all about any of the angles at this point, we cannot prove that these two triangles are congruent. As we explore congruent triangles further, you'll be able to develop proofs that these two triangles are congruent, but at this time, you need to know all of the corresponding parts are congruent, and we simply don't know that for these two right now. So there's no way to prove these two, right? So you can't prove it. There's not enough info. Theorem 4.1 is the third angles theorem. The theorem states, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So if angle A is congruent to angle D and angle B is congruent to angle E, then that must mean angle C is congruent to angle F. Let's prove the third angles theorem. Remember, when you're proving a theorem, you can't use the theorem. Theorems are rules that we can easily prove based on things we already know. So we're given that A is congruent to D and angle B is congruent to angle E. We need to prove that angle C is congruent to angle F. So our first step of this proof would be that angle A is congruent to angle D, angle B is congruent to angle E, because that was given. The next step would mean that their measures are equal, because that's the definition of congruent angles. We know that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. We also know the measure of angle D plus the measure of angle E plus the measure of angle F is 180. Why? Because that's the triangle sum theorem, that all three angles of any triangle are equal to 180 degrees. Therefore, we can take the 180s out and say that this can go here. So that's using substitution property. We can then take out the A and the B and put the D and the E in its place using substitution property. If we take DE away from both sides, then we'll have that measure of angle C is equal to the measure of angle F, because we subtracted. And if those angles are equal, then they are congruent, because the definition of congruent angles. We just proved the third angle theorem, so now we can use it. This whole chapter is about proving triangles are congruent. Right now we need to know that all of the corresponding parts are congruent in order to prove two triangles are congruent. We're given here that segment LM is congruent to segment LO. LM to LO. We're also given that MN is congruent to ON. We're given that angle M is congruent to angle O. And we're given that MLN is congruent to angle OLN. We want to prove that these two triangles are congruent. So the first thing we're going to do is state our congruent sides, because that was given to us here. We know that LN is congruent to itself. Both of these triangles have segment LN in them. They both have this segment. They share it. So it's congruent to itself. When something's congruent to itself, That's reflexive property of congruence. So now we have all three sides. We were given that angle M is congruent to angle O, and angle MLN is congruent to angle OLN. That's given. We can now say we know angle MNL, that's this one here, is congruent to angle ONL. Because if two angles of one triangle are congruent to two angles of the other, then the third one is. That's the third angles theorem. And now we have all of our corresponding parts are congruent, so we can prove these two triangles are congruent, because that's the definition of congruent triangles. You take a minute. See if you can prove that these two triangles are congruent, given that angle A is congruent to angle D, segment AE is congruent to segment DC, EB is congruent to CB, BA is congruent to BD. Can you prove that these two triangles are congruent? Give you a hint. There's a couple of steps that you need. And you should always recognize this special pair of angles in any proof. Take a minute and write your proof. Pause the video and see if what you have matches what I have. Let's see how you did. Angle A was congruent to angle D. That's given to you. You should then spot from a mile away that angle ABE is congruent to angle DCB because of those are vertical angles. And then you would know that angle E is congruent to angle C by the third angle theorem. The rest was given to you that all of the sides were congruent, and therefore you could prove triangle AEB is congruent to triangle DCB by the definition of congruent triangles.